All right, hello everyone. Welcome to our fourth, yes, our fourth, but final video on section 3.3. So we've been having a lot of fun in this section, learning different rules for differentiating different functions. Unfortunately, this part of the fun ends for now, but we will be continuing on to more differentiation rules in the future. And part of the reason we've spent so much time on this particular section is that these are really fundamental rules for differentiating functions that we're going to come back to constantly as we move on and learn other differentiation techniques. Okay, so as a reminder, in our previous video, one of the things we talked about was the derivative of a quotient of two functions. And part of the reason for that meme on the first slide is that a common mistake people make is the order in which they remember this rule. So first of all, looking at that top version of it, if we're trying to take the derivative of a function divided by another function, so in this case f of x divided by g of x, then the quotient rule says we do g of x times the derivative of f minus f times the derivative of g, all divided by g squared. And if you remember, a way to remember this is if I think of g of x as being the low because it's on the bottom, f of x as being the high because it's on the top, then what we're looking at here, remember, is low d high, so the low function times the derivative of the high, minus high d low, so the high function times the derivative of the low one, square the bottom, and there you go. So low d high minus high d low, square the bottom, and off you go. Okay, hopefully that's starting to get implanted in your brain. All right, so that's going to come up here where we're going to look at evaluating a derivative, but we're not going to have formulas for the functions this time. We're just going to have some graphical representations. So first things first, we're going to fill in this table over here using the graphs of the functions g and h. So the first thing we need to do, it's telling us, is find g of x, and actually I'm going to skip over the g prime, but do the h of x evaluating at the input of 3. So g of x, if I evaluate it at 3, looking over here, it looks like we get an output of 4. And for h of x, if we evaluate that at 3, it looks like we get an output of 2, right? Okay, let me rewrite that. There we go. All right, now let's talk about evaluating the derivatives of each of these at these particular points. Now, again, we're not using any formulas here, so those differentiation rules won't help us. But recall that a derivative helps us find the slope of a tangent line, right? Well, notice both of these functions we have, g and h, are basically made up of lines. When you have a line, it's really easy to find the slope of the tangent line or the slope of the graph at that point because you can just use the slope of the line. Now, I know it may seem weird to say that's a tangent line, right? Because, for example, in the function g, if I want to draw a tangent line at the point x equals 4, well, that line actually ends up just intersecting every point on the graph, right? So it's not actually a tangent line. But that's about as good as we can do. Okay, so looking at the function g, and we're trying to find g prime of x at 3, so we're trying to find basically g prime of 3. Well, that means we need the value of the derivative at x equals 3, which means we basically need the slope of the line there, which is going to be the slope of the function here, which looks like is up 1 over 1, up 1 over 1. So it looks like the slope is 1 there, be the value of the derivative. Okay, and that's supposed to be a 1. All right, similar thing for h prime of 3. So if we're trying to evaluate the derivative of h evaluated at 3, well, look at the slope of the line here, and it looks like we go from 2, 1, so we go down 1 over 2, so it looks like it's negative 1/2 there. Okay? So now that we have that and all that information filled out there, we are asked, or we're told actually, that the function k of x is given by doing the quotient of these two, so g of x divided by h of x, and they want us to use that information to find k prime of 3. Well, to do that, let's first find k prime. And again, this will not be a specific formula, but we can use our quotient rule here to help us, right? So we can use that low d high minus high d low. So our low function is h, so we do h of x times the derivative of the top, so g prime of x minus. Then we would have the high, so g of x times the derivative of the bottom, h prime of x. And then we square the bottom and off we go. So we'll have h of x squared. So this will be our representation of the derivative of k. And so if we're going to find k prime of 3, what are we going to do? Yeah, we're going to replace everywhere that we see an x, we're going to replace that with a 3, right? Because we're evaluating the function at 3. So k prime of 3, we're going to do h of 3 times g prime of 3 minus g of 3 times h prime of 3 all over h of 3 squared, which we know all of these values, right? We have those in the table. So h of 3 is 2 times g prime of 3 is 1 minus g of 3 is 4 times h prime of 3 is negative 1/2. All divided by h of 3, which is 2 squared. And if we work that out, let's see on the top left, 2 plus 2 is 4 over 4. I think we get a value of 1. Let me check my notes to make sure that's the same thing that I got. Okay, looks like it's the same. So I think we're good to go there. Sorry for the delay. Okay, and you guys can let me know later if I made some sort of a mistake here, but that's the idea with that. So we're using the quotient rule kind of in the more abstract there. All right, last thing for this section. So we have a function r of t equals t plus 3 over t minus 5. Some of you may recognize this from your classwork for this section. And they want us to find all values of t for which r prime of t equals negative 1. So in order to do this, if we want to find where r prime equals negative 1, what would be the first thing we need to do? That's right, we need to know what r prime of t is. And so I won't go through all the steps right now because this is for you to do as part of your classwork, but you'll see that the answer you get is negative 8 over t minus 5 squared. And so then we need to use that to solve for where r prime of t equals negative 1. So how would we do that? Right, we're going to set it equal to negative 1. So we'll do negative 8 over t minus 5 squared equals negative 1. Do some solving here. Now, in order to solve this, we notice we have the t minus 5 in the denominator, which we do not want. So we multiply by t minus 5 squared to get it out of the denominator. So when we do that, these t minus 5 squareds on the left will cancel out. Of negative 8 equals negative 1 times t minus 5 squared. We'll very carefully do our algebra here, right? So first things first, we need to do t minus 5 squared, which remember you can't just distribute the squared. You have to multiply this out as t minus 5 times t minus 5. So if you do that, you get t squared minus 10t plus 25 equals negative 8. You can distribute the negative 1 in there into the parentheses, but notice this is, well, you'll do that. And then also notice that this is a quadratic. And so in order to solve a quadratic, what do we have to do? We have to set it equal to 0. So when we do all of that, I'm going to actually just clear all this out. If you work out the algebra, you should end up with, I believe you'll have 0 equals negative t squared minus 10t plus 17. And then to solve this, we can try to factor, although this does not look like it'll factor, especially because there's a 17 here. So we can use our good friend, the quadratic formula. And if you do that, I believe you'll end up with 5 plus or minus 3 root 2 as the value for t there. Okay. Now, in case you're wondering why we did this, Cody, why would we ever want to solve for a particular value of the derivative? Well, as we move forward and learn more about derivatives, this is going to become in most handy for us when we're trying to find values where the derivative is equal to 0, because those are going to be significant points for us, and we'll talk more about that when we get there. All right, well, thank you guys so much for your attention. Have a great day.